Thanks, Jill. So obviously, everybody knows Deepak, the founder of the Chopra Foundation, and Dr. Rudolph Tanzi, Rudy, professor of neurology and at Harvard, and Deepak's cohort in authorship. So speaking of that, let's start with your new book, Super Genes. So it sounds like you're sort of pushing the envelope of conventional thinking as far as just how malleable DNA is. And so why don't you start by giving us an overview?
Well, the central basis of the book is that we've, in a couple of decades ago or more, we began looking at variations in the genome to predict disease, and this is the basis for pharmacogenomics and predictive or precision medicine. And now we've learned over these decades that of these mutations in the genome that cause disease, only a small percent of them actually guarantee that you're going to get a disease. In most cases, these variants just predispose you. And then you can mitigate your risk with your lifestyle, and this is where something called epigenetics comes in. And epigenetics is where basically based on lifestyle and habits, good habits, can program the gene activity. So you can't change the genes mom and dad gave you, but by programming their activity on and off, up and down, hundreds or thousands at a time, based on your diet, exercise, etc., you can live a much longer and healthier life. So you're in charge of programming your gene activity. They're your responsibility. And in that way, you can offset a lot of your risk when you look back at your family history for disease.
So as Rudy said, only 5% of disease-related gene mutations are fully penetrant, which means that, and that includes every disease, not only Alzheimer's, all the diseases that are associated with inflammation, autoimmune illnesses, cancer, etc., which means that 95% of chronic illness may be preventable, predictable, and one can personalize the data that you have through all the new technologies we have and create a new era of prevention, reversal, predictability, participation, and a process orientation towards the whole thing. Now, the reason we call the book Super Genes, it's not just about epigenetics. It's also about the microbiome and the integrated activity between the microbiome, the genome, and epigenetics. So, you have 10 times more microbial cells in your body than you have human cells. And if you actually count the number of genes, you have 150 times more microbial genes than human genes. And they respond to things like food, sleep, stress, emotions, exercise, breathing, even yoga and meditation. So this puts a whole new window into what we knew about genetics. If 150 times more genes are bacterial that you acquire on your way to the world, they weren't there in the 9 months of you were in the womb. But as you got into the world, you acquired the second genome, and it's only in the last 10, 15 years that we know about this integration.
Right, a lot's changing fast, and I think you're right. We're getting to the point where, between our biology and our choices, our environment, our lifestyle, and the ability to monitor, we can leave a whole lot left to chance. It's kind of exciting. So tell me, why now? What motivated you all to write the book now, as opposed to 10 years ago when things started?
Well, epigenetics is really the exciting thing. We've known for 40 years or so that your DNA can become chemically modified by your activities. So if you do the same type of diet or get the same amount of sleep or exercise regimen, or you're stressed out at the same level every day, over time, it's not just transient changes in how genes are turned on or off or up or down, but whole sets of genes get chemically modified by reactions called methylation or acetylation, where now they get programmed. It's like a semi-permanent programming where those genes are acting the same way all the time. Basically, good habits lead to good gene programs. Bad habits lead to bad gene programs. Bad habits like fast food diet, not getting enough sleep, can lead to inflammation in the body driven by actual gene activity. So it's your responsibility to determine what your habits will be, what's your stress level, exercise, diet, are you meditating, how are you dealing with your emotions, so that your genes can best serve you. And the book is called Super Genes because when your genes have been trained by you and your lifestyle to serve you best, then we call them super genes. That's the idea. But the reason why now is that over the last 5 years, there's been dozens and dozens of high-impact epigenetics papers in good scientific journals showing this is here for real, and that you may have certain family histories, but you can do a lot about it by programming your gene activity directly with your lifestyle. We studied those papers, and then we said, now what do we learn from those papers to say what you should do? And then the second section of the book, after we describe that, is here's the best thing to do in your life to make the best use of your genes. And the information only became available to do this just over the last 5 years or so. So it's a very timely topic.
Just like we had the Genome Project, now there's something called the Roadmap Epigene Project, and that's a multi-collaborative.
Yeah, Roadmap Epigenome.
Which is, several countries are participating in that. And that will be much more important than the Genome Project because it will link behaviors, emotions, even your internal life with gene expression. I mean, 10 years ago, 15 years ago, this would not have made any sense whatsoever.
Yeah, I mean, the balance between, nature versus nurture, what we can control and what we can't. I think it wasn't too long ago that everybody assumed, okay, this is your DNA and it's immutable, it's not touchable. And so choice always mattered, but it sounds like things are starting that we can change it, and maybe you're taking it a step further even still.
And these epigenetic modifications can be transferred to the next generation. In fact, in some animal models, up to 7 generations.
So your lifestyle right now, if you're in a reproductive age, can lead to changes in your gene activity or your gene expression. And for anything like what's happening in mice and other organisms, and it has to still be shown in humans, you're passing that on to the next generation. You're actually passing on new genetic information that you acquired as an adult to the next generation, which would be unheard of and crazy just only 5 years ago.
Right, so I guess you're saying choice in behavior is much, much more important than, it was common sense that it was important, but even more than we thought.
Choice, it's all about choice because your choices determine your experiences, your interactions. These are then directly affecting your body first at the genetic level.
That's the practical part of it. The theoretical, conceptual part of it is that no longer can we think of just genes, epigenes, microbiome, mind, brain, body as isolated systems. It's one process. Your mind, your consciousness, your brain, your genetic activity, epigenes, microbiome, environment, personal relationships, social interactions, professional interactions, it's one system.
Right. So, as you know, this is a CES, Consumer Electronics Show, and there are a whole lot of devices out there.
I'm wearing most of them.
Yeah. I'm wearing or have worn most of them. And so it seems to me that, because you talk about in the book about listening to what your cells are telling you, your body's messages, and it sounds like monitoring can only help.
Well, I just make a comment. I think where that's most applicable in terms of how we're going to use electronics from virtual reality to monitoring blood pressure, heart variability, et cetera, is that we need to start correlating changes with warning signs for disease. Because for most age-related diseases, including Alzheimer's, the pathology begins 15 to 20 years before symptoms. We've known this for heart disease. We know that once you have a tumor, you say you have cancer, you have to treat cancer. You don't wait for symptoms. And Alzheimer's, the plaque is building up in the brain 15 years before. That's when you have to hit it. So precision medicine is not complete when you just say, right patient, right drug. It has to be right patient, right drug, right time. You have to give the right drug at the right stage. If you treat the amyloid plaque in Alzheimer's in a full-blown patient, it's no good. It's like having a patient who just had a heart attack and you say, here, just take a statin, just take a Lipitor. You had to do that 15 years ago. So now we're learning all that. We need to learn, not just with biomarkers and imaging, all of the different telltale signs from remote sensing of when someone's getting in trouble for various diseases. Now, with the types of products we're seeing here in digital health, that's possible for the first time.
Also, when you start to integrate these different technologies, one that's measuring heart rate variability, another that's measuring brain waves, another that's looking at breathing patterns, another that's looking at stress from a different point of view, like galvanic skin response. When you start to integrate these with what you're already seeing, your sleeping patterns, who you were engaged with, what kind of conversations you were having, when were the periods you were stressed, the GPS is also telling you where you were, and now with immersive experiences in virtual reality, you can actually change the ecosystem. You know, we call this the real reality, but the mechanism by which this is produced is exactly what the virtual reality is replicating. So when you start to realize that your biological organism is an activity in the ecosystem, and you can change the ecosystem to actually change the way you think and behave, you now have a new tool for not only bioregulation, but actually changing gene expression, microbiome, epigenetic activity, and therefore going beyond prevention, looking at treatments for, we already know that coronary artery disease is reversible. Do we know that about diabetes? Yes. Type 2 diabetes, we know that. Do we know that about rheumatoid arthritis or bronchial asthma associated with a lot of inflammation in the body? So, you know, I would go a little bit pushing the envelope that actually these technologies will be the future treatments, not just preventive bioregulation monitoring, they'll be the treatments. Instead of taking a pill, you could go and get a session in a virtual reality realm and come back with lower blood pressure, more relaxed blood arteries, and less plaque in your brain.
Well, as you said, it's a state of mind. So if you feel it, it is. Now, you have a couple of gadgets. They're not monitoring at this stage.
Well, Rudy and I have a gadget called the Dream Weaver, which actually feeds light and sound into your brain. Starts with high frequency light, and it's also synchronized with a meditation experience, and it takes you into a forest or into space or whatever, but it'll change your brain waves within 10 minutes, put you in a dream state, even a sleep state. It's called the Dream Weaver. It's out now, and actually you can download the software from iTunes or Google or whatever, and it'll give you the experience. But now we want to go beyond that into the virtual reality and augmented reality experience, taking the same ideas.
Right, yeah, so I think this is just the beginning, but, you know, stress is such a big killer, you know. If you look at the main enemy with aging, it's inflammation of the body. You know, not acute inflammation like around a wound or a sore knee, but chronic asymptomatic inflammation in the body. It's involved with everything from heart disease, diabetes, Alzheimer's, you name it. And the main causes of inflammation are addressable with the types of products that we're seeing here in digital health. Monitoring sleep. I mean, sleep has never been more important for staving off Alzheimer's disease. I mean, we now know if you're over 40 or 50, you need to try to get 7 to 8 hours of sleep. It's not an option. It's not a good idea anymore. It's necessary. That's the only time your brain cleans itself out of the pathology that causes Alzheimer's 15, 20 years before symptoms. Things like this. Exercise, one of the best ways to stave off Alzheimer's. Much of what we need to do to stave off Alzheimer's and inflammation, you can now monitor with electronics. And you can also treat with electronics, especially for mitigating stress, because stress causes inflammation, and it's something that's probably the most amenable to virtual reality treatment.
See, there's something called leaky gut. I think many people probably are aware of this, but when you're stressed, the microbiome in your stomach gets inflamed, and then the enzymes that are in your gut, they kind of leak out into the circulation, and then they do what they're supposed to do. They digest proteins. So there's a lot of now information that leaky gut And the leaking of enzymes into the circulation may be responsible for the inflammation, also for type 2 diabetes, even type 1 diabetes, because they digest the islet cells. So as we are looking at this, and we're looking at what vagal stimulation can do, by the way, it slows down your heart rate, it increases heart rate variability, it decreases the leaky gut syndrome. Now with all these technologies, including immersive experiences in virtual reality, but also stimulating the vagus nerve just through electromagnetic impulses, which you don't even feel, you would be able to change the whole ecosystem again here. Of course, these are not out there, but this is what the future is going to be.
Right. Are you looking at moving more toward kind of melding the things that you're doing with?
You see, all these years we've been talking on the level of molecular biology. I think we need to move beyond into understanding the body as an energy field, an information field, and dare I say, a consciousness field as well, because ultimately everything starts with consciousness, intention, and we're looking at stress. But you know, only recently have people started to look at what happens when you feel euphoria. When you feel an internal state of euphoria, somebody sends you an emoticon, you get a dopamine hit right there and then. People aren't looking, are beginning to look at the biological expression of joy, of love, of compassion, of equanimity, which was impossible before. But now you look at dopamine markers, you look at oxytocin, you look at opiates, serotonin, which was not possible before. So I predict that just like you can look at sugar levels or cortisol levels through saliva and sometimes through skin, we'll be looking at other proteins, correlating them with gene expression. I see that totally within the realm of possibilities. And then looking at that, ultimately even correlating that at a big level with traffic accidents, hospital admissions, crime rate, social unrest, leadership, etc. This is a whole different ballgame.
There are two big movements going on in medicine that I think will really start blooming over the next 2 decades. One is that instead of thinking about drugs that treat one enzyme or one reaction, like taking a Lipitor or a statin to hit one enzyme that controls cholesterol, and doing research that way, that now we're starting to look at it in a systems way. We're looking at the entire expression of the genome in disease, or even looking at what does the expression of the genome look like in wellness, and thinking about coming up with treatments that will actually affect many different genes at once based on the patterns that come out of systems biology that says this is good for you. Now, how we're going to do that will also not just be with traditional drugs like pharmaceuticals, but taking advantage, as Deepak said, of the energy field, taking advantage of the fact that we're electromagnetic beings. So we're seeing now treatments that use magnetism, that use electronics, direct
ultrasound,
current, even ultrasound. So we're going to see a big movement in non-drug treatments, but also trying to affect changes in many different systems of the body now that we can measure them, and going for overall wellness rather than piecemeal hitting one enzyme at a time. That's probably going to be the biggest movement in medicine over the next couple of decades.
Can you say a few words about our studies that we're doing together, both meditation and SPTI?
Well, so we recently did a clinical trial looking at what is the effect of 1 week of meditation on the body, looking at gene activity on the whole genome, looking at an enzyme called telomerase, which is the anti-aging enzyme to keep cells young. It grows the tips of the chromosomes. We looked at markers for inflammation. We even looked at markers for Alzheimer's disease. And what we found was, just blew our minds, because after 1 week of meditation, we could see a gene pattern that was so different than the control group, which was just at the same resort having fun, but not meditating, that with 96% certainty, we could say this person meditated, that person didn't. 96% certainty based on the overall gene activity. telomerase activity, the anti-aging enzyme, up 40%. And that was done with the Nobel laureate Liz Blackburn, who discovered it. So just so many, even the Alzheimer's marker for amyloid went in the right direction. We didn't expect such a big result. And so that paper is now under review and hopefully will be out soon. But it says that that's an example where you don't have a drug, but just simple meditation can cause so many salutary effects.
And so now we're actually taking that to the next stage with all the other lifestyle factors, not just meditation, but looking at diet especially, because the microbiome comes into contact with what you eat. The first thing that happens is you influence the behavior of the microbiome, which, as we said, is the second genome.
Yeah, it's fascinating. I mean, as we kind of, over the past decade, see this huge box of possibility in DNA, that there's another box down there about proteins and enzymes, and there's a lot more to explore. So let me ask you, we're getting short on time. You have a room full of technology folks, gadget freaks. What do you want from them? What can they do for you?
Well, we would love to collaborate with them because there are so many technologies, but if you think in a holistic systems biology, then it's very clear that there has to be integration of all these different technologies. And for me, the most exciting thing is immersive virtual reality, augmented virtual reality, where looking at experience, changing your experience changes your biology. Simple. If you want to change your biology, you change your experience. And that means you can change any experience through the 5 senses, internal experience, environment, relationships. So what we can do with these amazing technologies is look at how to integrate them into a systems biology framework and then take that to the next step. How do you immerse yourself in an environment that you can create? You can choose the environment. Imagine if I could immerse myself in a battle zone and feel what the enemy is feeling and recognize that they're feeling just like me. Well, maybe I can have this technology increase my ability to have compassion and empathy and understanding and recognize that my enemy is myself in a different uniform. Imagine if I could immerse you in an environment which is so toxic, where you could see the actual biological changes that are happening with the lifestyle that you are in, and then give you an experience that is totally at contrast with that. It would change the way you think. It would change the way you feel. It would ultimately change behavior. All these years we've known the right behaviors. So every New Year's we make resolutions and we break them in 3 weeks. Well, you have to have an internal experience that shifts your consciousness in a way that it's irreversible. And that's what the new technologies can do for us.
Okay, great.
I would just add to that, if we could have a non-invasive way to read the warning signs of disease early, from even reading, how you smell. I mean, there are people who say they can tell if someone has disease based on smell, and some of them have been tested for Parkinson's disease, and we're not taking full advantage of reading the skin, of reading the external, even factors in the breath or in the tongue, looking at telltale signs of whether disease is coming, and having an interactive system where if some of that can be helped by de-stressing or recommending tips about diet, or like my watch tells me to stand up every hour, or yells at me, isn't happy when I don't exercise. But having an interaction of electronics that tell you if you're in a little bit of trouble, and empowering you with lifestyle changes that help you to offset disease. If we could do that more and more, I think we won't have to worry so much about having pharmaceuticals to help us after it's too late.
Right. Yeah, so good points. And thank you both, Deepak, Rudy. This was a pleasure. Appreciate it.
Thank you very much.
Thank you.